In today's lesson, we're going to be covering writing word problems from equations. I put this slide here so, guys, as we go through, we can add keywords that we're going to be seeing inside the word problems and identifying them as being an addition, a subtraction, a multiplication, or a division keyword. So you can just add the words to this chart as we go along. All right, so the steps we're going to follow today is first, we're going to read through the scenario, obviously. Second, we want to highlight any keywords or phrases or identify any numbers that are used in the scenario. We want to identify the variable and define it. So those would sound like let X equal the number of cars, or let P equal the number of people. Then we want to translate the words that we've highlighted and the key phrases that we've highlighted into an equation. Of course, we're going to solve it. And then we want to make sure that we're writing our answer in a sentence so that it does answer the question that was posed to us. Okay, so let's take a look at our first example. Anthony's Pizza sells pizzas for $10 plus $1.50 per topping. If Sally purchased a pizza for $17.50, how many toppings were on Sally's pizza? Okay, so first of all, let's highlight any keywords or phrases that are used so that we can then translate them a little bit easier later. So hopefully they sell pizzas for $10. Also, that color green is not showing up very nicely, so I'm going to switch to blue here, guys. Okay, so pizzas for $10. We also have $1.50 per topping. And then Sally purchased her pizza for $17.50. Everything else is kind of, well, I guess the question's important. How many toppings were on Sally's pizza? So we want to figure out that at the end, but that's pretty much the important parts of this scenario. Okay, so next we're going to go ahead and pick a variable and define it. So I don't know, do we want to use just X, or maybe do we want to pick T since we're finding how many toppings? And actually, I think that's the one I'm going to go with. I'm going to say T equals the number of toppings on Sally's pizza. Sorry, my handwriting looks terrible there. I'm writing with a touch screen, so that is using my pointer finger. So it kind of looks like I'm like maybe 5. But anyway, okay, we want to go ahead and translate our keywords and phrases into an equation. So we see that Sally's going to pay $10 for her pizza no matter what. That is the base cost for a pizza. So I'm going to say $10. But then it says plus $1.50 per topping. Hopefully that keyword of plus is clear, but we want to add that to our add column in that little table that I put on that first slide. Okay, so $10 plus $1.50 per topping. Per is another key word, which per means to multiply. I'm going to abbreviate that MLT. Okay, so you want to again add per to your words under multiply. So $1.50 per topping. Topping we said was T. So $1.50 times T. I'm just going to put $1.50 T because without a symbol in between a number and a variable, it does mean multiply. Okay, we know that Sally purchased a pizza for $17.50. So this expression of 10 plus $1.50 per topping is supposed to equal $17.50. Okay, so we've translated the keywords and phrases into an equation. So our next step is to just solve it. And we've talked about solving an equation in a previous lesson. So we know inverse operations from here. So let's go ahead and subtract 10 from both sides. I would get $1.50 t is equal to 7.50. And then we're going to divide both sides by $1.50. Okay, so if we divide that 750 divided by 150, we get the number of toppings is equal to 5. T equals 5. So to answer the question, how many toppings were on Sally's pizza? 5 toppings are on Sally's pizza. I'm not going to write out that whole sentence, guys, because one, I'm getting short on room, and two, my handwriting looks terrible on this touchscreen, but I at least identified the number and what it's representing. 5 toppings. Okay, the next example says a hot air balloon begins its descent from a height of 576 feet. The balloon descends at 25 feet per minute. After how many minutes will the hot air balloon reach a height of 100 feet? Okay, again, I'm going to highlight any keywords or phrases. So it's descending. That's important. And actually, I'll highlight it down here. Descends at 25 feet per minute. We also know that it starts at a height of 576 feet. We want to know how many minutes will it reach a height of 100 feet. Okay, let's go ahead and define our variable. We want to know how many minutes. So maybe we'll pick M this time. M is going to represent the number of minutes. And again, we're finding the number of minutes for the hot air balloon to reach 100 feet. Okay, let's go ahead and write our equation. We see that the hot air balloon is at a height of 576 feet. It's descending, so its height isn't going to increase, its height is going to decrease. So we're going to subtract. So descends is a keyword for subtraction. 25 feet per minute. We see that per again, which we used in the last example, and that meant multiply. So 25 per times the number of minutes, which we said was M. And we want to know when is it going to reach 100 feet. So equals 100. Okay, let's go ahead and solve that equation. We're going to subtract 576 from both sides. We get negative 25m is equal to negative 476. And we're going to divide both sides by negative 25. All right, if we do that, I'm going to pull up my calculator real quick here. We have negative 476 divided by a negative, oh, it won't let me put a negative sign in here. Okay, so let's talk about signs separately. A negative divided by a negative is going to make a positive value. So really, I'm just dividing 476 by 25. Okay, and I get 19.04. So M equals 19.04. The question said how many minutes, so let's say approximately. So rather than saying m equals, I'm going to use the approximately equal to symbol, 19. So about 19 minutes. All right, that was our second example. Taking a look at the next example, it says Stella buys a shirt at the mall and pays 6% sales tax on the cost of the shirt. If Sally spent a total of $26.24, what is the original cost of the shirt? Okay, so we know that Stella's buying a shirt. She's also going to pay 6% sales tax on the cost of that shirt. And we know that she spent a total of $26.24. And we want to know what's the original cost of the shirt. Okay, so if we identify a variable, I'm going to say S. S equals the cost of the shirt. There's a couple different ways that we can set this up. So I'm going to show both ways, and then you guys can pick which way you like best. So she's going to buy the shirt. We don't know the cost of the shirt, so that's S. It says that she also pays 6% sales tax. So we're going to have to multiply 6% or 0.06 times the cost of the shirt and add that on to the cost of the shirt. So S plus 0.06 times S, and that's going to equal the total value of the shirt, or the total cost of the shirt, I should say, $26.24. Another way to think about this, guys, is she's going to spend 100% of the cost of the shirt plus the 6% sales tax. So really, she's spending 106% of the cost of the shirt. Of is a keyword for multiply. So 106% is 1.06. 106% of the shirt's cost. Of means multiply, so I'm going to multiply that by S. And again, that equals the total cost, $26.24. These two equations are actually equivalent because the first step in solving this one on the left side of my screen is I would have to combine like terms. So S, or 1S, plus 0.06S is going to give me 1.06S. So I actually get the same result when I go to solve the one on the left as setting it up with the idea of the total percentage right off the bat. So whichever way works better for you. In order to solve that 1.06S is equal to 26.24, we're going to have to divide both sides by 1.06. So again, let me go to my calculator, 26.24, and we're dividing that by 1.06. We get S is equal to, 24.75. So the cost of the shirt was $24.75. Again, we want to write that in a complete sentence. I'm not going to try to write that out on this slide, but I'll say it. The cost of the shirt is $24.75. Here's our next Example, it says the perimeter of the two figures below are the same. What is the length of the longest side of the triangle? Okay, so keywords that we need to identify: perimeter. Hopefully we remember what perimeter means. Oops. There we go. Perimeter. It means add up all of the sides or the distance around an object. So we're going to add up all the sides of those two shapes. We know that the perimeters are the same. The same is a keyword for equal. And then we're trying to find the length of the longest side. All right, they've already identified x as the variable that's being used in this scenario. So x is going to represent the side of that quadrilateral that is identified by x. Okay, let's go ahead and find the perimeter of each one of those shapes. So the triangle, we're going to add up those three sides. The first side, x minus 2, plus the second side, 3x minus 1, plus the third side, 2x minus 1. We've got lots of like terms that we're going to have to combine there. I'm also going to write the expression for the quadrilateral. So if we add up all the sides, the first side is x, plus the next side is 4x minus 7, plus the next side is again x, and the fourth side is 2x minus 3. Okay, let's go ahead and combine like terms of the triangle first. So if I identify those like terms, I'll put them in a different color here. We've got x, 3x, and 2x. So if I combine those like terms, 1x plus 3x plus 2x gives me 6x. Okay, the next set of like terms, we have -2, -1, and another -1. So again, if we add those like terms together, -2 plus -1 plus -1, that gives me -4. Let's do the same thing for the quadrilateral. So our first set of like terms, we have x plus 4x plus x plus 2x. If we add all of those together, 1x plus 4x plus 1x plus 2x, that gives me 8x. And the like terms of -7 and -3. If we add those together, -7 plus -3 gives me -10. So this first expression of 6x minus 4 is representing the triangle. And the second expression, 8x minus 10, is representing the quadrilateral. It says that the perimeters of the two figures are the same. So the same means equal. Okay, so let's go ahead and solve this equation. I'm going to subtract 8x from both sides. So we get -2x minus 4 is equal to -10. And let's add 4 to both sides. We get negative 2x is equal to negative 6. And last step, divide both sides by negative 2, and I get x equals 3. So we know that this shortest side of the quadrilateral is 3. However, that was not the question that was asked. So this is why it's really important to always refer back and make sure you've answered the question that was posed. So we were asked, what is the length of the longest side of the triangle? So we know x equals 3. So if x equals 3, x minus 2 would actually mean 3 minus 2. So that side is just 1. If we look here, 2x minus 1, that means 2 times x minus 1, or 2 times 3 minus 1. That gives me 5. And then the last side of that triangle, 3x minus 1, that means 3 times 3 minus 1, and that gives me 8. So if I look, I'm looking for the longest side, and that is 8. So 8 is the longest side of the triangle. Okay, our last example that we're going to take a look at together says Manuel is being offered jobs from 2 different companies. Frey Incorporated is offering Manuel a base salary of $65,000 and an extra $1,500 for every year he works. Stieber Company is offering Manuel a starting salary of $70,000 and an additional $1,000 for every year he works. After how many years will Frey Incorporated and Stieber Company have the same salary? All right, lots of important information going on. So let's first talk about Frey Incorporated. It says he's offering Manuel $65,000 as a base salary and an extra $1,500 for every year he works. Okay, if we look at Stieber Company, it's offering $70,000 for a starting salary and an additional $1,000 for every year. And the question says, how many years will Frey Incorporated and Stieber Company have the same salary? Okay, let's go ahead and identify our variable here. So it asks us how many years. So we need to know what's the number of years until they're equal. So I'm going to say y is our variable that we're going to use, and it's going to represent the number of years when the 2 salaries are equal. That says years. Okay, let's go ahead and translate first Frey Incorporated. We start at $65,000. So that's our starting salary. And an extra, so we're earning more than that, so plus $1,500 for every year. So $1,500 for every is another way that you could say per. So $1,500 per year. So times the number of years, which is y. Okay, let's take a look at Stieber Company. They offer $70,000 as a base salary and an additional, so again, plus $1,000 for every year. $1,000 for every, again, means multiply by the number of years, y. We want to know after how many years will they have the same salary. Same means equal. So we want to set the 2 expressions equal. All right, let's go ahead and solve it. So we're going to subtract 1000y from both sides. That gives me 65,000 plus 500y is equal to 70,000. We're going to subtract 65,000 from each side. So we get, I'm going to write it up here at the top, 500y is equal to $5,000. And we're going to divide both sides by the 500. All right, we get y equals 10. So in 10 years, these two companies would have the same salary. All right, guys, those are the examples that we're taking a look at today for writing equations from word problems.